Hello everyone. So let's see this concept, the slope at t equals to 0 plus in RC circuits. But before that, let's solve a simple mathematical problem. Okay, they are asking find the dxt by dt at t equals to 0 plus, or they can write it dx0 plus by dt, or they can write it x dash 0 at 0 plus. So tell me if I am doing right or wrong. What I am doing, I'm putting x of 0 equals to, I am putting t equals to 0. So x of 0 will be 6 into 0 square plus 3 into 0. So that would be 0. Now I am differentiating it and I am calling it this value, and differentiation of 0 will be 0. So is this analysis correct? This is wrong. Okay. So what should be the approach? If they are asking the slope at t equals to 0 plus, that means first you need to differentiate. First you will differentiate. Okay. First I will differentiate. What is the differentiation? That is 12t plus 3. Now I will put t equals to 0. Okay. Now I will put t equals to 0 or 0 plus, whatever I am putting. So my answer is 3. So basically dxt by dt at t equals to 0 plus, or dx0 plus by dt, or x dash 0 plus is 3. Okay. And one more thing you saw here is that note. What is that? Even if x of 0 is 0 volt, sorry, x of 0 is 0, then x dash 0 plus may not be 0, right? In the function, if you put t equals to 0, you may get 0 there. Okay, but it's not necessary that after differentiating and putting 0 you will also get the same value. Okay, it can be different. Here you can see, if you put t equals to 0 in this function, you get 0 voltage, 0 answer, you get 0. But if you differentiate it, you get 12t plus 3, and then you put 0, you get 3. So here in this example, x of 0 was 0, but x dash of 0 was 0 plus, you may say. X dash of 0 plus was not 0, it was 3. Okay, so I hope you have understood this concept. Okay, well and good. Just simple mathematical problem, but many times students get it wrong. Okay, that's why I have explained it here. Okay, let's see the questions now. You have to find VR dash, VR dash 0 plus, VC dash 0 plus, and IC dash 0 plus. It should have been written where VR dash 0 plus shows dVRT by dt at t equals to 0 plus. Okay, we just need to find the slope at t equals to 0 plus. Find slope at t equals to 0 plus. So from where I should start? Let's start with the simple equation. So let's just break down the circuit now. How will the circuit look like? The switch is getting close at t equals to 0. I will write 5 ut. At t equals to 0 plus they are asking. Okay. Both are grounded. You can make them like this and then make it ground. R and C. There is this current. IC is flowing. Okay. Capital IC they are calling it. So I will also write capital IC. So now I can write the equation. 5 ut is equals to IR plus 1 by ICR. 5 ut equals to ICR plus 1 by C integration IC dt. It would be better if I write ICT dt, and here as well if I write ICT. So ICT into R. Okay. Now what is my target? My target is to find the differentiation of the current. My target is to find that differentiation of the current. So what I will do? I will differentiate on both sides. Differentiating both sides, right? I will differentiate both sides. So 5 ut will become 5 delta t. This will become r dic t by dt, and this will become, integration will be gone, so ic t by c. At t equals to 0 plus, at t equals to 0 plus. Now tell me what will be the value of 5 delta t at t equals to 0 plus. What will be the value? 0. Why so? What is the graph of 5 delta t? This is the graph of 5 delta t. At t equals to 0 plus, this is only at t equals to 0. At t equals to 0 plus, what will happen? It will go down to 0 only, right? So let's write it on next page. At t equals to 0 plus, what I will do? 5 delta 0 plus is equals to r into, this is at, and this is only the time domain value, by dt plus ic at t equals to 0 plus by c. Okay, I will just write down what is delta t? Delta t is infinity for t equals to 0 and 0 when t is not equals to 0. Okay, and what we are talking about? We are talking about t 0 plus. We are talking about t 0 plus. At t equals to 0 it is impulse, and at t equals to 0 plus it is 0 only. So this 5 delta t will go down to 0. So now this goes down to 0. This is r dic 0 plus by dt. Tell me what is the value of ic 0 plus? What is the value of ic 0 plus? At t equals to 0 plus, this capacitor will be shorted, the current will be 5 by r. So it would be 5 by rc, because ic 0 plus is 5 by r, right? So what will be my final answer? dic dt is 5 minus 5 by r square c. This is my final answer. Or what will be the method 2? This is the method everyone expect you to answer. Okay, in the interview if they ask you this question, by this method you will solve. In written test you can solve by any method, but in the interview you will solve by this method. Okay, but in written test what you can do, but you shouldn't do in written test as well. Okay, but there is one more method. Just write down the equation of ICT. What is the equation of ICT? That is 5 by r e to the power minus t upon tau. What is tau? Tau is rc into ut. Just differentiate it now. Now many of the students will do the wrong differentiation, still they will get the correct answer, but we will do the correct differentiation. U into V will apply, because this is also a time domain function, right? U into V will apply first as it is, differentiation of second plus differentiation of second minus t by rc into 1 by rc, then rc will come t by 2. Yeah, differentiation we are doing. Okay, so t by rc it will go into second as it is. Now you will put t equals to 0 plus, right? This will already be delta t, like e to the power minus t by rc delta t can be replaced with delta t only. I have explained this concept a lot of time, right? Delta t minus 0 you can write, then 0 you will put here, so this will become 1 only. So this complete function can be replaced with delta t only, right? And if you put t equals to 0 plus, this delta will go down to 0. At t equals to 0 plus, this will go down to 0. So I am putting t equals to 0 plus by dt. So 5 by r, this will go down to 0. This will be 1 by rc, and this will be u of 0 plus. What will be the value of u of 0 plus? What is ut? This is ut, right? Ut is 1 for t greater than 0 and 0 for t less than 0. U of 0 plus will be 1 only, right? And here delta of 0 plus would be 0 only, right? Why so? Just make the graph. This is the graph, right? At t equals to 0 you can't define the value, but at t equals to 0 plus you are having 1 volt, right? So at t equals to 0 plus you are having 1 volt. Okay, I should have written it. At t equals to 0 plus, this value will be 1. So basically your answer would be minus 5 by r square c. So this is my final answer. Okay. So by this method also you can solve, but in the exam also or in the written test or everywhere I want you to solve by this method. This is just equation, you don't use your brain here. Okay, but you are using your brain here. Now let's find VRT and VCT as well. Okay, so we will find VRT now. So second, what we will find? dVr 0 plus by dt, that we are finding. So 5 ut plus VRT plus 1 by c integration I dot IC dot dt from 0 to t. Okay, one thing we can do here is that we can differentiate here and put the value as well. Okay, yeah, we can do that, differentiating on both sides. On both sides, what we will get? 5 delta t plus dVrt dt plus ICT, actually I should have written ICT here, ICT by c at t equals to 0 plus, this will become 0, this will be dVr 0 plus by dt at t equals to 0 plus, what is the value of IC? That is 5 by r, so it would be 5 by RC. So dVr 0 plus, it would be minus 5 by RC. So this is my second answer. By equation you can solve on your own, or I should solve. What is VRT? VRT is, initially it is 5 volt and then decays down to 0. 5 e to the power minus t by RC ut. And then you can just differentiate it and put t equals to 0. Okay, so I will just differentiate it, this as it is, minus dVr at t equals to 0 by dt, that is 5 by RC. This is what you are getting, minus 5 by RC. Okay, by equation you can solve on your own, but here also I have solved. Okay, let's comment on dVCT by dVC. Now let's comment on dVC 0 plus by dt. How will you write the equation? 5 ut is equals to ICR ICTR. Now no one will write VCT here because you don't know the slope at t equals to 0 plus, right? ICTR plus VCT. Now if I differentiate it, what will happen? 5 delta t into R dICT by dt plus dVCT by dt. This will happen, right? And now I can find this value, but for that I need this value. Although I know this value now because I have already derived, but if I hadn't derived it, this was my first problem. So why should I write IC here? I can change it, right? So I will try to change it in terms of VC. So in terms of VC, I want to change my this value. So in terms of VC, I will change. So what is ICT? ICT is C dVCT by dt. Okay. In the previous problem, I didn't use anything that I derived beforehand, right? I did not use anything that I derived beforehand. Here I derived this value, but I don't want to use this value. I am solving all the problems independently, right? So 5 ut is equals to RC dVC by dt plus VC. Now I don't even need to differentiate, right? Because I already have this term. So 4 It's not necessary that every time you will be differentiating, right? For t equals to 0 plus 5 u of 0 plus RC dVc 0 plus by dt Vc 0 plus. What is the value of Vc 0 plus? Vc 0 plus is 0 volt only, right? Initial voltage at the capacitor, that was 0 only. What is the value of U of 0 plus? That is 1, right? So it would be 5 equals to RC dVc 0 plus by dt. So what will be the value of dVc 0 plus by dt? That would be 5 by RC. Okay, so this is my final answer. Got my point? Well and good. Easy question, right? You can solve by the equation as well now, but that's not a matter of concern now. So that's how we are advised to solve. In the interview, if someone is asking you this problem, they expect you to solve by this method only, not by the equations. And in the exam as well, if there is this simple RC circuit, this was very simple RC circuit, right? Very simple RC circuit. So if they are asking this simple RC circuit, you should solve by the equations only. Just try to solve as much as by the equation, by the method, by this method, not by the final equation, not by the final linear equation. Okay, that is not also linear equation. I want to say, don't solve the problem by the exponential equation. Just try to solve by the differential equation. Okay. Now this is the problem. So it may happen that in exam it doesn't click you so early how to solve this problem. So in the exam you can solve the problem by simply by writing the exponential equation, then just differentiate it and put t equals to 0 plus. Okay. But in the interview, if they are asking this question, they will not be happy if you solve the problem by exponential equation. So you need to solve the problem by writing the differential equation only. So just try to think as much as you can think, then just see the solution. Okay. So you have to think. I need the complete equation in terms of Vc. That's my target, right? Let's just call this current is I. I can simply write 5 ut is equals to, what will be my differential equation? 5 ut is equals to IR plus Vc, right? Now the main task is replace I in terms of Vc. Now task is replace I in terms of Vc, right? This is my task. So tell me, what is the current here in this circuit? What is the current? C dVc by dt. And what is the current here? If this is Vc, the current will be Vc by R. Well and good. So I is equals to Vc by R plus C dVc by dt. Did you get this point? So in exam or in the interview, if you are able to crack this thing very quickly, okay, if you are good enough, if you have done good enough practice, you will be able to crack it. Okay, C dVc by dt, Vc by R, that's it. Okay, so I will just replace it. This is equation 1, this is equation 2. By equation 1 and 2, 1 and 2, 5 ut is equals to 5 ut is equals to, what is the value of I? That is Vc by R plus C dVc by dt into R plus Vc, right? 5 ut is equals to Vc plus Rc dVct, I should write actually, dVct Vct. Even this current will be a function of time only. Okay, this will be also a function of time, ITR. Why it will be a function of time? Because this is a combination of the capacitor current and the resistor current. So both will, so capacitor current is a function of time. So this current will also be a function of time. RC dVct by dt plus Vct, right? So 5 ut 2 VCT plus RC dVCT by dt, where they are asking at t equals to 0 plus, at t equals to 0 plus 5 u of 0 plus 2 Vc of 0 plus RC dVc 0 plus by dt. So tell me, what is the value of Vc 0 plus? That is 0 volt only. And what is the value of U 0 plus? That is 1. Right? Vc 0 plus. The capacitor initially will act as short circuit. Right? Initially it will act as short circuit. So it will be 0 only. Or one more thing. This would have been very easy if I did not replace it with I did not need to replace it with Vc, and I did not need to replace I with Vc. I can solve it from here as well. Right? 5 ut, can I solve it? No, I can't solve it, because I will have to differentiate, and then I don't know the value of this thing. I don't know this thing, right? Dit by dt I don't know. So I will have to differentiate. So I can't really solve it from here. Okay. I just thought I can solve it. Yeah. So 5 will be equals to RC dVc 0 plus by dt. So dVc 0 plus by dt is 5 by RC. This is my final answer. Got it? This is my final answer. Okay. And method 2 will also be there. What is the method 2? By using the equations. So how will you write down the VCT equation? VCT equation is, initially it is 0 volt, and then we are going to 2.5 volt, right? From 5 to 2.5 we are going. So 2.5 into 1 minus e to the power minus t upon 2 ut. What is the value of tau here? Tau value is RC by 2, right? Tau value is RC by 2. So simply differentiate it, dVc by dt, that would be 2.5, this as it is, into differentiation of the other one, plus second as it is, and ut as it is, and differentiation of this. So it will become e to the power minus t upon tau ut. And we are talking about t equals to 0 plus, so this will be 0 only. So dVc 0 plus by dt, this will go down to 0, so this complete factor will go down to 0 only, right? So 0 plus 1 by tau, and this will be 1 only. 0 plus 1 by tau. What is the value of tau? That is RC by 2. So basically your dVc 0 plus by dt is coming out to be 5 by RC only, right? Well and good, just the equation, but you just need to take care of the mathematics. Okay, well and good, easy problem. Okay, this method I would like more rather than this method. Okay, yeah, so this was the problem, finding slope at t equals to 0 plus. So in any circuit you need to think and find the values. Okay, so you can think on your own and then find the value. Okay, let's move on to the next concept, that is switch capacitor concept. Okay, this is very important concept, and no one teaches this concept. Okay, so I will teach very deeply. Okay, so we have a capacitor C1 with initial voltage V1. Then we have a capacitor C2 with initial voltage V2. Both are connected in series. Then, like, both are connected in series, and there is no switch, nothing. Both are open-ended. So no current is flowing through them. So they will hold their voltage, right? So basically what I am saying, your VC 0 minus is V1 volts, and your VC2 0 minus is V2 volt, right? Now what is happening at t equals to 0, the switch is getting closed. At t equals to 0, switch is getting closed. That means V voltage is there and a complete path is there. So now the current will flow. So what will happen at t equals to 0 plus? At t equals to 0 plus, circuit at t equals to 0 plus, what will happen? This V voltage will come. This will be replaced with the battery V1, and this will be replaced with the battery V2. there are no resistor, only the voltage source. So what will be the current? The current would be V minus V1 minus V2. This is the voltage divided by 0. That means infinite impulse current. That means capacitor will change its voltage immediately. So how they will change? That's the main task. So let's draw the circuit now. Okay, let's draw the circuit. So this is the circuit. Now both of the capacitors are connected in series. So let's just call this current as IC1 and this current as IC2. Since both capacitors are connected in series. Capacitors are connected in series. That means IC1 is equals to IC2, right? IC1 is equals to IC2. That means C1 dVC1 by dt is equals to C2 dVC2 by dt, right? Change in charge will be the same. Change in charge will be the same. Or I can write C1 delta T to dt get cancelled. So C1 delta VC1 is equals to C2 delta VC2. I can write, right? So let's just assume because of voltage source V, because of voltage source V, if the change in VC1 is delta V, then change in VC2 will be what? What that will be? C1 by C2 delta V. That means if C1 develops its voltage by delta V amount, then C2 will develop its voltage by C1 by C2 into delta V amount. Let me repeat the statement. Because of voltage source V, if C1 develops its voltage by delta V amount, then C2 will develop its voltage by C1 by C2 delta V amount. Initially it was having V voltage. So basically what is happening now? This is capacitor C1, this is capacitor C2. This is voltage V. This is C1, this is C2. Initially it was having V1 voltage, right? But now I am saying it has developed. Now I am saying initially it was having V1 voltage. Now it has developed V1 plus delta V. Now what will happen to this voltage? Initially it was having V2 voltage. Initially it was having V2 voltage, but now it has developed C1 by C2 delta V voltage. If it had developed delta V, it would have developed C1 by C2 delta V, right? If VC2 had developed delta V, then what will be the change in VC1? If the change in VC2 was delta V, then what would be a change in VC1? That would be C2 by C1 into delta V, right? But here the change is delta V, so it would be C1 by C2 into delta V. So now you can apply the KVL. Applying KVL, and this is VC1, this is VC2. At t equals to 0 plus only we will reach the steady state, right? Applying KVL. Because there is no resistor involved and infinite current is there. So at t equals to 0 plus we will reach the steady state. Applying KVL, V equals to VC1 plus VC2. Right? So V equals to V1 plus delta V plus V2 plus C1 by C2 delta V. Our task is to find the value of delta V. Right? So it would be C1 plus C2 by C2 into delta V. So from here you get the value of delta V, that is what is the value of delta V? Is there anything wrong in the calculation? No, nothing is wrong. So delta V you get is C2 upon C1 plus C2 V minus V1 minus V2. That is the delta V you get. Okay. So what will be the value of VC1? So VC1 would be V1 plus delta V. V1 plus delta V. And what is the value of delta V? Delta V is C2 upon C1 plus C2 into V minus V1 minus V2. This is VC1. This is VC1 we are getting, right? What will be VC2? VC2 would be V2 plus C1 by C2 delta V, right? It would be V2 plus, people are celebrating Diwali after 2 days of Diwali, that too at 12 a.m. at night. I don't understand this. Okay, no problem. So what will be VC2? It is V minus V1 minus V2. So it would be V2 plus C1 upon C1 plus C2 V minus V1 minus V2. This will be your VC2 value. That's the steady state value. Okay. So if we draw the graph of VC1 and VC2. Okay, so now we will draw the graph, but we can't really draw the graph here because we don't know if this value is greater than V1 or less than V1. Like initially we are having, if we draw the graph for VC1, so initially we are having V1 voltage, then we are having V1 plus this voltage. Now we don't really know what is the value of this voltage, right? We don't really know what is the value of this voltage, right? So we can't really draw the graph. Okay, so let's forget drawing the graph because it can be greater than V1, it can be lesser than V1. We will solve a problem, then we will draw the graph. Now we have derived this thing, but in the exam you are not going to do this derivation, right? So how will you write the value? That I will tell you now. Okay. So now the thing is, again, anytime the firecracker may burn, okay, anytime sound may come, okay, so please bear with it. Okay, so yeah, so in one step I need to write the value of VC1 and VC2. So how will I write? First I will write the initial voltage. So first I am writing the initial voltage, that is V1 plus, I will see what is the total voltage in the circuit. What is the total voltage in the circuit? From here I will start 0 plus V minus V1 minus V2. Total voltage is V minus V1 minus V2. Now for C1 I am writing, so I will divide the voltage in the inverse proportion, because in case of the capacitance we divide the voltage in the inverse proportion. So for C1 I am writing, so I will write C2 upon C1 plus C2. What did I do? First I wrote down the initial voltage plus, then I saw the total voltage, that is V minus V1 minus V2, then I just divide in the inverse proportion. So that's it, that's my final answer. So that's how you will write it. Okay, in one step only. Initial voltage plus total voltage in the circuit and divide in the inverse proportion. That's it. Okay. And how did we reach to the formula? In the interview, if they ask you how you are writing this formula, then you can tell them that if this is given delta V, this would be given C2 by C1 delta V, then you can just derive it and get to this answer. Okay. So this is VC1 and VC2 we are getting. Okay. So now let's see a question. So it will be easy for you. So I will just write down the question. In the question as well, you just need to find VC1 and VC2. Steady state. Okay, I will just pause it and then write down the question. So this is the question, you can read it. You need to find the VC 1 value at t equals to 0 plus and Vc2 value at t equals to 0 plus. Just as you close the switch, steady state will be reached. That we already know. Okay. So Vc1 0 plus and Vc2 0 plus we need to find. Okay. Yeah. So initial voltage are 2 volt and 1 volt. Vc0 minus is 2 volt. Vc2 0 minus is 1 volt. Okay. So 2 volt and 1 volt are the initial condition, and also we need to draw the waveform of IC. What is IC? This is IC. Okay. This is IC. So let's just write the value of Vc1 at t equals to 0 plus. What will be the value of Vc1 at t equals to 0 plus? Initial voltage, that is 2 volt. What is the total voltage in the circuit? 6 minus Vc1, that is minus 2 minus 1 into inverse proportion 2c by 3c, right? So this is 3 2, so it would be 4 volts. What will be Vc2 at t equals to 0 plus? Can you tell? Without writing the equation, it will be 2 volt, because if this is 4, this will be 2, or you can write down by the formula as well. 1 plus, what is the total voltage? 6 minus 2 minus 1, in the inverse proportion you will divide, right? So it would be 1 plus 1, 2 volt. So basically, what is the waveform? Okay, in the next page I will draw. What will be the waveform of Vc1 and Vc2? Vc1, first it was 2, then it went up to 4 volt. First it was 2, then it went up to 4 volt. To 4 volt. What about Vc2? First it was 1, then went up to 2 volt. First it was 1, then went up to 2 volt. From 1 volt to 2 volt. Right? Now you need to write down the equation of IC1 and IC2. So you can write it down, right? IC1 is equals to IC2 is equals to IC actually. IC1 is equals to IC2 is equals to IC. So I can write IC is equals to C1 dVc1 by dt. That would be C1 is the value having CO capacitance, right? Or I can write C2 dVc2 by dt, and C2 is having 2C capacitance, so dVc2 by dt. So these expression I have. So C into change in the voltage. Change in the voltage is 2 volt. So my answer would be 2C delta T, right? And here 2C into change in Vc2 voltage. What is the change in Vc2 voltage? That is 1 volt. So it will be also 2C delta T. So basically, what will be my waveform for IC? Simply an impulse of 2C. And what does 2C show here? 2C shows here the charge, right? That means we are giving 2C charge to both of the capacitors, right? So this is my IC, that is 2C delta T, or I shouldn't write 2C delta T, I should just write 2C, because this shows the magnitude, this shows the magnitude. So my ICT is 2C delta T. Okay, these questions may look easier to you, but whenever these questions comes in exam, everyone, some tries Laplace transform, some do something. Now everything that can be asked in the exam, we have first seen the complete derivation, whatever the concept, then we have just narrowed it down to one formula. Initial voltage, complete voltage in the circuit, divide in the inverse proportion, that's it. There can be multiple options. First you can solve it by Laplace transform as well. Okay, well and good, very easy method, solve by Laplace transform, you can do that. Another one, you can solve by superposition theorem as well. That's also a good method. How will you solve by superposition? First you will see the effect of voltage V only, then you will see the effect of voltage V1 only, then you will see the effect of voltage V2 only. That's how you will solve by the superposition. So you can try that on your own. Okay. If there are multiple capacitors, if there are multiple voltage sources, so how will you solve? So at that point of time, superposition will be in action. Okay. So you can try on your own by superposition. Maybe in the end of the lecture or in the end of the complete transient lecture, I can bring those videos. Okay. So, but you should try on your own by the superposition theorem. This method I have told, well and good, right? Easy method. This question also we have solved. We have drawn the waveform. We have also write down the equation of current, right? So this was an easy concept. This concept is called as switch capacitor. Okay. So how the voltage in the capacitor is changing instantaneously. That's what we have studied. Now let's solve this simple problem. You have to find the expression of I1 and I2. Okay. Try doing it on your own first. So tell me what will be the value of I1 at t. First tell me the order of the circuit and time constant. What will be the time constant? Open circuit the current source. Open circuit the current source. This C1 and C2 will come in series, right? So time constant would be R into C1 C2 upon C1 plus C2. So this will be the time constant, right? This will be the time constant, right? Now what about I1? So let's see I1. I1 at t equals to 0 plus. What is the value of I1 at t equals to 0 plus? What is the value of I2 at t equals to 0 plus? Initially what will happen? This capacitor will be shorted, this capacitor will also be shorted. So simply 5 ampere current, one resistor and a short circuit path. So the complete current will be flowing like this, right? So the complete current will be flowing through the C2 capacitor only. So I2 at t equals to 0 plus would be 5 ampere. And what will be I1 at t equals to 0 plus? That would be 0 ampere. Now what will happen? I think I should write it on next page only. At t equals to 0 plus. At t equals to 0 plus, I1 at t equals to 0 plus was, I1 was 0 ampere because no current was flowing through it, and I2 at t equals to 0 plus was, I2 at t equals to 0 plus was what? 5 ampere, right? What will happen at t equals to infinity? Both capacitor will be open circuited, right? Okay. Both capacitor will be open circuited. This is C1, this is C2. Is there any ambiguity? Can you say in both of the resistor, in both of the capacitor, the current will be 0? Can you say that? This is I1 and this is I2. In both of the capacitor, the current will be 0. Can you say that? No, you can't say that. Why so? Because from here we are having 5 ampere current. That's for sure that we are having 5 ampere current here. Here we are having 5 ampere current. So 5 ampere has to be equals to I1 plus I2. You can't say that I1 and I2 both are 0. If both are 0, where is 5 ampere current going? 5 ampere current is coming. This is also 0, this is also 0. So where is 5 ampere current going? So both I1 and I2 are not 0. So what will you do? In case of ambiguity, at t equals to infinity, what is the frequency content? Omega equals to 0. That means Zc is very high. That means what? Series combination of Rc can be replaced with a single capacitor, right? So how will the circuit look like now? Not here, I should make it here only. With a single capacitor. So how will the circuit look like? 5 ampere current source. This series RC will be replaced with a single capacitor C1, right? And this series RC will be replaced with a single capacitor C2. This is 5 ampere current. This is I1 and this is I2. What about I1 at t equals to infinity? 5 ampere current will be divided into C1 and C2 in the proportion, because in case of capacitance the current is divided in proportion. So 5 C1 upon C1 plus C2. And what about I2 at infinity? That is 5 C2 upon C1 plus C2. So what about I1? It is rising from 0 to this value 5 C1 upon C1 plus C2. So if I am writing the expression of I1t, from 0 to it is rising to 5c1 upon c1 plus c2 1 minus e to the power minus t upon 2 u of t, with time constant being r c1 c2 upon c1 plus c2. Okay, well and good. What about I2t? It is rising from 5 to some value, that is 5c2 upon c1 plus c2, and it is coming from 5, right? So it is coming from 5. So initially the value has to be 5. So it has to be 5c1 upon c1 plus c2 e to the power minus t upon 2 ut. How did I write this expression? Look, if I know the value at infinity, I just need to make sure that at t equals to 0, I need to have 5 voltage. So I know that I will be putting t equals to 0 here. So this would be 1. So I need to write the expression such that this value becomes 5. So I just thought I should write 5 c1 upon c1 plus a2. If it doesn't click to you, you can simply use this formula, y of infinity, y of 0 minus y of infinity e to the power minus t upon 2. But how did I write it? I am telling that thing. Okay. You know the value at t equals to 0. You just need to write down the expression such that it becomes the same value at t equals to 0. Okay. So at t equals to 0, we are getting 5 only. So that's how I wrote it. Okay. Otherwise, you can use the formula. It will take one more step, but it will be the same as this. Okay. So these are the expression of I1t and I2t. Okay. Well and good. I just took this example so that like you understand the concept. In current source as well it can happen. So whenever there is an ambiguity, you will always go with omega equals to 0, omega equals to infinity. Parallel combination of RC will be replaced with the single capacitor in case of omega equals to infinity, and series combination of RC will be replaced with the single capacitor in case of omega equals to 0. Okay. So in case of ambiguity, you will go to this thing. Okay. Well and good. So in the before going to the next lecture, this we will be dealing in the, okay, this is impulse voltage input. Okay, so we will deal this in this lecture only. So we need to see RC circuit with impulse voltage input now. Okay, what will happen for impulse current input? Step, right? If impulse current input is there, we will have a step that we have already studied, right? But now if impulse voltage input is there, so what will happen? So you need to draw the waveform of V0 and IC. Okay. So this is your voltage input. So what is your voltage input? What is your voltage input? This is your voltage input. That is having a magnitude of Vs, right? So what does this Vs shows? This Vs is flux. I have explained this concept, right? Why is it flux? What is EMF? EMF is d by dt, d phi by dt. So EMF into time, voltage into time, voltage into second brings the, what is the flux, right? Voltage into second is the flux. So Vs is the flux. Okay. So what is happening at t equals to 0? At t equals to 0, you can say at t equals to, yeah, at t equals to 0, at not at t equals to 0 plus, at t equals to 0. At t equals to 0, capacitor will be short circuited. Capacitor will be shorted, right? So let me draw the circuit at t equals to 0. This is R, and here we have this impulse voltage, that is Vs delta t. Tell me what will be the value of IC at t equals to 0 plus at t equals to 0. What will be the value of IC at t equals to 0? Vs delta t by R. That means impulsive current. Impulse current. What will happen? This Vs by R delta t current will flow through the capacitor and it will charge the capacitor, right? So what will be Vc value? Vc value from t equals to 0 minus to t equals to 0. From 0 minus to 0 you can write. So Vs by R, because this current is only there at t equals to 0 only, right? So Vs, I will write it in 1 by C ICT from t equals to 0 to t equals to 0 minus to 0 only, delta t. So it would be 1 by C from 0 minus to 0 Vs by R delta t dt. So basically our voltage at t equals to 0 would be Vs by Rc from 0 minus to 0 delta t dt. It would be Vs by Rc. What is the differentiation of delta t? That is integration of delta t, that is ut from 0 minus to 0. So Vs by Rc u of 0 minus u of 0 minus. Look, you don't really define the value of u of 0, but you can take it as a 1 for now, because the voltage at t equals to 0 and 0 plus would be the same. At t equals to 0 minus, Vc is 0, but at t equals to 0 plus it will be different. So you can take it as 1 for now and this as 0, because u of 0 minus is 0, right? This is Vc 0. What is Vc 0? That is Vs by Rc. So because of the impulse current, it develops some voltage, that is Vs by Rc, right? We have applied an impulse, Vs by R delta t current is flowing. That means it has developed Vs by delta t, Vs by Rc. Circuit at t equals to 0 plus. What is happening at t equals to 0 plus now? Input is gone. Vs delta t is gone. V in t, that is Vs delta t, will be 0 after t equals to 0, right? That means V in at 0 plus is 0 volt. Input is gone. So now what will happen? This resistor will come, one end of the resistor will be grounded and the other end of the resistor will be connected to the capacitor, but the capacitor is having initial voltage of Vs by Rc. Now what will happen? This is Vc, right? Yeah, this is Vc. Now what will happen? This Vs by Rc voltage will get discharged with time. Vs by Rc voltage will be discharged exponentially. Like we have solved this circuit, right? A capacitor is having V voltage with C capacitance and resistance R in parallel. What will happen? This V will be discharged through this resistor from V to 0, right? So this Vs by Rc voltage will be discharged with the time constant Rc, right? So this Vs by Rc voltage will be discharged with time constant Rc. So finally, what will be the Vct expression? It was 0, then suddenly it rises to Vs by Rc, then it discharges to 0 volt, right? Are you getting my point or not? With time constant Rc, so time constant being Rc. Okay, so basically I want to say Vc infinity would be 0 volt. Vc 0 plus was Vs by Rc, then it discharges to 0 volts. From Vs by Rc, it discharges to 0. What about IC? IC was shown like this. IC was shown like this. So this is IC. Commenting on IC. IC 0 was Vs by Rc, right? Sorry, not Vs by Rc, Vs by R, right? Vs by R delta T you can say, or Vs by R delta 0 you can say, or Vs by R delta T you say. There is one thing only. So initially it is impulsive, then because of this capacitor, the IC value at t equals to 0 plus is what? Minus Vs by R square C. Are you getting this point? This voltage by the resistance. Vs by Rc voltage by the resistance, that is R. So Vs by R square C. So this is the current, but in the negative direction. Vs by R square C. So this is the current. Then the current goes down to 0. So IC infinity goes down to 0. So basically what is ICT? Initially an impulse at t equals to 0. then value becomes Vs R square C and goes down to 0, right? So this is the expression of ICT. I hope you are getting my point. I will tell you one more method, but in the interview this method should be used. Okay, other methods I will tell you. Okay, no problem. So for VCT and ICT we will draw the waveforms. So in case of VCT, from 0 to suddenly it rises to some value, 0 initially, then suddenly it rises to this value and then decays down to 0, right? From 0 to it rises to Vs by Rc, then decays down to 0. What about the current? Current, this axis I should have made much better. This I should have made. So initially there is an impulse current that has the magnitude of Vs by R. Not the magnitude, sorry, the area, Vs by R. Then suddenly the current goes down to minus Vs by R square C and then discharges to 0, right? With time constant being tau equals to Rc. This is the time constant, tau equals to Rc. Are you getting my point or not? So this was the one method that we solved without using anything, any Laplace transform, anything, simply by the concepts. Let's go to the method 2 by Laplace transform. By Laplace transform also you can solve this. So what was your input? Forget about the input. First let's make the circuit. That is the resistance, that is the capacitance, that is 1 by Cs, and now we have the input. Okay, my input was Vs delta t, so simply the input would be Vs only. V in t was Vs delta t. So what will be the Laplace transform of V in t? Laplace transform will be Vs. So Laplace transform would be Vs only. This is I of s. So basically your I of s would be Vs upon, because of the impulse input, it would be simply Vs upon R plus 1 upon Cs. R plus 1 upon Cs. So Is would be Vs Cs upon RCs plus 1. Okay. So I need to break it down. CVS I am taking common and then I am writing S upon RCS plus 1. What I can do, I can multiply and divide with RC. Multiply and RCS it will become, then I can do plus minus 1. Did you get what did I do here? CVS I took common, instead of S I wrote SRC and then divided by the SRC, then I did plus minus 1. If it's a solid, plus minus 1 will be 0, RC and RC will be cancelled, you will get the same expression. So that's how we did. So CVS by RC 1 minus 1 by SRC plus 1. This is your IS. So I can write it like this: CVS by RC minus this RC I can take outward, right? Okay, C and C are getting cancelled actually, right? I will not cancel it actually. C and C are getting cancelled, so I can write Vs by R, Vs by R minus Vs by R, and I am taking RC common from that. So it would be R square C into 1 upon S plus 1 by RC, right? So now taking the inverse Laplace. Now I am taking the inverse Laplace. This is Vs by R, so it would be Vs by R delta t, right? Now for this, Vs R square C e to the power minus t by RC ut. What did I do? Inverse Laplace of a constant. What is the inverse Laplace of constant? That is a delta t. What is the inverse Laplace of this value? 1 upon s plus a, that is e to the power minus at ut. This is what I did here. Okay, Vs by R delta t minus Vs by R square C e to the power minus t by RC ut. Okay, so this is what I did here. Okay, so this was for IS. Now for VCS, shall I leave up to you? VCS, no, I should solve it on my own. So VCS would be 1 upon CS upon 1 upon CS plus R into the input voltage, that is Vs only, in Laplace transform, right? So it would be 1 upon RCS plus 1 into Vs. So you can write Vs by RC into 1 upon S plus 1 by RC. So this is VCS. So what will be in time domain? It would be Vs by RC e to the power minus t by RC ut. This will be the answer in time domain. Okay. So this was the method 2. Okay. This was method 2. There is one more method. Let's see method 3. Method 3. So I will just if this is an LTI system is linear time invariant system. I don't actually remember if I have told you this concept of linear time invariant system. I have told you what is linear system, what is time invariant system. That I have told. So if there is this linear time invariant system, so if I am applying a step input, I am getting a step response, right? Now if I differentiate the input, okay, what I am doing, I am differentiating the input. Differentiate the input. So if I differentiate a step input, what will happen? I will have an impulse input, right? Impulse input. So if there is this impulse input, I will, if I am differentiating the input, I can differentiate the output as well. So I will get an impulse response. So are you getting my point? If you know the response for a step input, then you can simply differentiate it and get the response for impulse input as well. Let's just see one thing. This is my R, this is my C. Okay, this is my R, this is my C, and this is V in. This is T equals to 0, 0 to Vs. Okay, what will be my output? What will be my V naught for this input? What will be my V naught? Step response. V naught T would be, it will rise Vs 1 minus e to the power minus t upon tau ut. This will be my final answer, right? Now what I am doing, I am differentiating it. Differentiate. What is the differentiation of a step? That is impulse, right? So I will have an impulse of magnitude Vs. Vs, right? This is my input only. So my V in T would be Vs, not the magnitude, area. Okay, Vs delta T. This is my input. Now for getting the output, what I will do, I will also differentiate here and get my output. Differentiate, you will get your impulse response. Impulse response. So what will be my impulse response? Impulse response. What will be your impulse response? Simply it will be d by dt of Vs into 1 minus e to the power minus t upon tau ut. So first, as it is, differentiation of the second, plus second as it is, differentiation of the first. Oh, sorry, second as it is. So this value will become delta t only. First as it is, differentiation of the second. So this value, okay, this value will become 0, because 0 you will put here and this will become 1, so this will go to 0. Are you getting my point? Xt into delta t, what is xt into delta t? That is x of 0 delta t, right? If you put 0 in this equation, this will become 0 only. So 0 into delta will be 0 only. So this is what is happening here. Okay, so this will become 0. So your final response is Vs by tau. Tau is Rc. So Vs by Rc e to the power minus t upon tau ut, right? So this will be your final impulse response. So this is how also you can solve by the equation. Okay, this is also a good method. Same you can do it with the current, right? Same you can do impulse response for current. Response for current. Same thing can be done with the current as well. What was the expression of step response? To step response for current. Step response for current. What was the expression? That was Vs for step response. What was the expression? Initially Vs by R, then decays down to 0, right? Vs by R and then decays down to 0 into ut. Into ut. If you just differentiate it, you will get your final answer. So Vs by R will come in common. First as it is, differentiation of second, plus differentiation of this e to the power minus t upon tau by tau ut. Basically Vs by R delta t, because this will be 1, minus Vs by tau is Rc, so R square c e to the power minus t upon tau ut. That is the impulse current response. Impulse current response. A current response for impulse voltage input, right? This is also a final answer. Okay, so have you understood all three methods, right? So in the interview you will be solving with this method. Okay, method 1. If the interviewer tells you to solve by this method, that integrate the output or differentiate the output, then you will solve by this method. Okay, and in the exam you can solve by this method, because this will be complete mathematics only. So I have told you all three methods. I hope you are comfortable with all the concepts that I am teaching, right? Switch capacitor we have seen. In this lecture we saw switch capacitor, we saw impulse input, we saw this simple example, right? What else we saw in this lecture? we saw the slope at t equals to 0 plus. So these three things we saw. Okay, these are very important as well. Okay, so in the next lecture will be the last lecture for the concepts, at least for written test and gate students. But for interview there are few more concepts left that I will add on. Okay, but next lecture will be the last one for the gate aspirant and for written test of interviews. But in the interview they can ask much more concept from transient. So that concept we will discuss from, not from transient, from RC. From transient, RL is left, RLC is left, LC oscillator is left. So transient is not completed, only RC circuit is completed. Okay, so from next onward we will see one more concept, then we will solve many problems, then we will move on to RL circuits. Okay, thank you.